then the probability that the difference between number of heads and number of tails equals to 1 is 0. Okay, coin is tossed 3 times, so probability that number of heads equals number of tails. Okay, when a coin is tossed 3 times, possible outcomes are what? H, 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 that's 1. H, H, T, that's again. H, T, H, H, T, T. I'm just listing out all the possible outcomes that we are receiving. T, H, T. Then we have T, T, H. And we have T, T, T. Okay? So how many are there? 1, 2, 3, 4, 5, 6, 7, 8. 8. So there are 8 possibilities of tossing a coin 3 times and getting the outcomes. We need the probability that the difference between number of heads and number of tail is 0. Why do you ask? It's because when the difference between number of heads and number of tails is 0, which means they are occurring exactly same time. They are occurring exactly same number of times. So that's what it's asking, that the difference between number of heads and number of tails equals to 0. But with 3 tosses, it's impossible to have equal heads and tails, since 3 is an odd number. So the only possible outcome are 3, 0, 2, 1, 1, 2, or 0, 3. Okay, so it's either 2 heads, 1 tail, or 1 heads, 2 tail, or no heads, 3 tails, or 3 heads, no tail. Only four possibilities. So getting exact amount of tail and head is not possible. So probability here is 0 because that event is impossible. Okay, next question. Ravi went to buy fruits for himself from a shop. There was a basket of fruits containing 10 apples and 20 oranges, out of which 3 apples and 5 oranges are rotten. If he chooses 2 fruits randomly, what is the probability that either both are oranges or both are not rotten? Okay, so probability that either both fruits are oranges or both are not rotten. So what do we have? We have apple, 10, oranges, 20, okay? We know 3 are rotten, so I will just put 3A dash. In 5 oranges, O dash as 5. So how many not rotten? Not rotten is 7. Not rotten oranges are 15. The question is asking probability that either both fruits or oranges or both are not rotten. What is the probability that either both are oranges or both are not? Okay, so probability that both fruits are oranges or both are not rotten. Okay, so how many total fruits we have? We have total as 30 fruits, including rotten ones. So how many possible ways are there to choose? Okay, your total outcome is not going to be 30. Why? Because you have to choose 2 oranges out of 30, 2 fruits out of 30, which means you're going to use combination. 30 choose 2. Okay, that is going to give that is going to give you 435. There are 435 ways to choose 2 fruits, which can either be apple or oranges. Okay. Now, what if they both are oranges? How many ways? So out of 20, how many can you choose? 2 oranges. How many ways are there you can choose 2 oranges? 20 over 2. That's 190. Okay. And how many are there not rotten? Not rotten. So there are 22. How many 2 fruits can you choose out of 22 which are not rotten? So 231. And how many fruits are there where you can choose oranges and they are not rotten? Both the fruits you choose are oranges and not rotten. How many oranges are there? 15. So you're going to choose not rotten oranges. That is going to be 15. Choose 2. Choosing 2 fruits which turns out to be oranges and they are not rotten. So 15 choose 2. You're getting 105. So how many favorable outcomes are there? Both are oranges and both are not rotten. So both are oranges is what? 190. There is 190 ways of choosing both oranges. Okay, that's one. Plus, how many oranges how many not rotten are there? So there are two probabilities. Choosing both apples, both fruits as oranges, that number is given. Choosing both not rotten is given, 231. And you are going to subtract when chosen fruit turns out to be an orange and it's not rotten, 105. So you get 316 over 435 to get the probability. Yeah. So your total probability is going to be 316 over how many possible outcomes are there? 435. So that's how you get the answer. I hope that this makes sense, right? So probability that both are oranges, okay? You have both the oranges, not probability, number of ways. You are choosing two apples, which are just oranges. You're choosing two fruits, which are not rotten. And then you're subtracting chosen fruits, which were oranges and not rotten. When you subtract that from not rotten and oranges, you get just oranges, or both are not rotten, because you're removing oranges which are not rotten. Okay. I hope this makes sense. This is a tricky part, but if you logically display this equation in your mind in terms of words, then this will make more sense. Okay. Yeah. Okay. During an IPL match, a batsman generally hits boundaries. Either he will score 4 or 6 whenever he will get a full toss delivery. He will chuck the delivery, i.e., he won't score any run. If he gets the bouncer, he will score 0. If the ball is in swinger, however, if he faces the outswinger, he will score either 1 or 2. If he faces a short pitch delivery, he will score either 3 or 5. Consider the situation as a sample space whose outcome is the type of ball faced and the runs scored for that delivery, i.e., bounce or 0, will be considered as one of the outcomes. Find the total number of outcomes in the sample space. Okay, so when there's a full toss, which means just a direct ball is thrown at a player, the player has two outcomes. And what are those? He either scores 4 or 6. But if there's a bouncer, ball goes very high up, he scores 0. There's one outcome. If there's in swinger, I don't know what that is, but turns out he's not going to score any, 0, and it's again one outcome that we can expect. If there is outswinger, then again we are getting 0, which means he's not going to score anything, and the outcome is 1 as well. No, in outswinger, it says he's going to score 1 or 2. So 1 or 2. So there are two outcomes. In short pitch, again, I don't know what that means, but I know he can score 3 or 5, which means, again, two outcomes. So each type of delivery and its possible run is one outcome. So total number of outcome is what? Total outcomes. Starting from here, 2 plus 1 plus 1 plus 2 plus 2, which means 8 outcomes. So there are total 8 outcomes, which is going to come from this sample space. Okay, so I hope this makes sense.